All right, guys, we're going to try to make this lesson video quick because I've only got about 10 minutes till my next class. But what this is going to be 5.5, our introduction into polar coordinates. We're just getting through a little bit here, just getting our feet wet with the different type of graphing. So this is going to be part A. There will be a part B where we do a little bit more about changing between different types of coordinate systems. But first, we're just going to talk about what even is polar coordinates. Polar coordinates are different than our normal coordinate system because normally you guys graph on a rectangular grid. But not everything in the world, and you guys can read your notes in here, not everything in the world works rectangularly so well. Like you think about the Earth is round, and if you actually are talking about an airplane flying around the Earth, it doesn't actually fly in a straight line the way we picture it. It's actually a flying curve to go around the Earth, even though it feels like it's going straight. So there's a different type of system for when you're dealing with scenarios like that, because the Earth is in fact round. So when you look at satellites that are going around the Earth, you talk about airplanes flying, we really should be thinking more of like compared to like a circular or spherical type of system. So what we have here is done as a little picture of the way that a point is kind of graphed on our polar coordinate system. Instead of using an X and a Y, like normally we would say, oh, to the right, this many, and up this many. Instead of looking at it that way, we're going to look at this as a radius, or R, and theta. And you're going to see that this really does correspond very, very clearly with our unit circle. And so hopefully, as we do a couple of problems, that knowledge of our unit circle is going to make the graphing on this type of system much easier. Okay, but again, the idea is we're looking at this radius and a theta. And let me show you how this works. We're going to go on the next page, and you'll see a polar grid, right, which is round, not rectangular, right? Okay, so here's how this works. I'm going to plot this point A that you see, example 1. This first value is R. This second value is theta. And I'm going to go to the right 2, okay, because I want to go out a distance of 2. But then we're going to go, instead of going straight up like you do with the Y coordinate, we're going to follow the curve of my graph. And we're going to go to pi over 3. Okay, now there's a little spoke on my wheel right here that says pi over 3. That's the spoke I'm going to get to. So I've gone over to 2 for my radius. And then we're going along this little curve until we get to that spoke on the wheel. That is point A. Okay? Look at the next one, right? The next one says 1, 3 pi over 2. So I need you to visualize, where is 3 pi over 2 on your unit circle? Well, 3 pi over 2 has always been down here, right? But I need to look at this as a radius of 1, and then we're going around 3 pi over 2. So radius of 1, going out here to 1. 3 pi over 2 follows this curve all the way around 3 pi over 2 down here. There's B. All right, so then the next one. What about the next one? We have 3, then 4 pi over 3. So I go all the way out to 3, which is as big as my grid was made for. And then I go 4 pi over 3. So think, where is 4 pi over 3? Is that in quadrant 1, 2, 3, 4? 4 pi over 3 is located over down here. Pi over 3 would be pi. 3 pi over 3 would be pi. 4 pi over 3, a little bit further, we're looking at over in here for your C. And then the last one here I have is D, which is 2 negative pi over 6. It's a little bit trickier because we have this negative here, but I want you to remember what we did when we had negative angles. I'm going to go out here to the 2, and then I'm going to open the negative direction, which is clockwise. Pi over 6, right in there. That is D. We're going to make a little note to ourselves because I think sometimes those signs can mess with you. Also, it's possible for like if your R value, it could be negative. If my R value is negative, that would mean I'm opening to the left first. And then you're having to decide which way to go, which direction. So the easy rule of thumb, I don't want you guys to think about theta as if theta is positive, open up. If theta is negative, open down. I don't want you to think that way because it actually can mess you up in the long run, especially if your R is negative. It's kind of opposite. So what I want you to think instead, here's a little reminder, and we had these notes back before Christmas, but I know it's been a while. Or it was back in, I don't know, maybe 4.2, 4.3, something like that, whenever we did that. Okay, so this is reminder. Okay. We're going to say positive angles. They open counterclockwise. All right, and then negative angles. They open clockwise. So we're going to follow that. All right, I got one more example for you guys. Well, maybe two. It just depends on time. We'll see. All right, so here's example 2. It says plot and label the following polar coordinates on our grid. All right, I would like you guys to pause the video and try this one on your own for just a moment. See if you can plot where these points are. Come back when you're ready to see the answers. Okay, so we're going to see A should have been at 2 pi over 4. Hopefully you've already tried this. 2 pi over 4. There's A. Oops. There we go. Okay. Then we have B is at 2 negative 7 pi over 4. If I go 2 and then negative 7 pi over 4, I should be opening clockwise. That's going to go around, and it's actually going to land in the exact same place that A was. Wild, right? 2 9 pi over 4. Now that is positive, so I'm opening counterclockwise. 9 pi over 4 is more than a full rotation because a full rotation would have been 8 pi over 4 or 2 pi. So I'm looking at a full rotation and then some more. This is actually in the exact same place. And then one more, negative 2, 5 pi over 4. Negative 2 would mean I'm going to the left, and then 5 pi over 4, that's positive, so I should be opening counterclockwise. So if I open counterclockwise, I'm opening this direction, and you actually land in the exact same spot, which I know sounds crazy. Fun fact, there's infinitely many different points that you can have or different coordinates that you can have to represent a point, which is kind of cool, but it's also kind of annoying at the same time. Okay, real fast, I'm going to try to do one more example because I think that would put us in a better stopping spot. So, all right, looking at example 3. First of all, they tell me to plot a point. This is 3 and then 5 pi over 6. Going to land us right here. 3, 5 pi over 6. Okay. Then they said, write the polar coordinates for the point 2 different ways. So remember how we said there's an infinite number of ways to do it? Well, I can write this many different ways. I could find a coterminal angle by thinking, okay, what if I go an extra rotation? Or if I went negative instead? So I want you to think about like, what would that look like? There's, again, many ways to do it. I could either add 2 pi or subtract 2 pi. Either way will give me a coterminal angle. Let's add 2 pi for fun. Okay, technically that's over 1, so in order to add them, we need to get common denominators. So that's 12 pi over 6. And if you add those, it makes it 17 pi over 6. So I actually get a coordinate point at 3, 17 pi over 6. There's 1. But what if I want a different one? For fun, let's see what it would be if I used a negative 3 for the r. That would have meant that I went to the left 3. Then I would be going pi over 6 to get to my next value. The question is it positive pi over 6 or negative pi over 6? since I would be going to the -3 and then opening counterclockwise, right? If I'm opening, oh no, that's not counterclockwise. I'm opening clockwise. Since it opens clockwise from there, that's a negative for that if I had a -3 in the front. Again, there's infinite ways to do it, but that, in a nutshell, is polar coordinate graphing. All right, guys, for this video, that's going to be it. And stay tuned for the next one where we are going to practice going between rectangular and polar coordinates and seeing how they compare to each other. All right, I'll see you in the next one. Bye.